Before looking at factors of algebraic terms, let's have a look at factors of whole numbers. Now we know that if we talk about factors of numbers such as 12, we're talking about numbers that divide exactly into 12 with no remainder, in this case whole numbers that divide into 12. And an easy way to think of those numbers is to pair them. So for example, 1 and 12 are two numbers which are factors of 12, and that's true because 1 multiplied by 12 equals 12. Alternatively, what you could also say is 12, the original number you're talking about, divided by 1 equals 12. So the two numbers here shown in brown, 1 and 12 in the last line, they're the factors of 12. Two other factors are 2 and 6, because we know we can multiply those numbers to form 12, and also 3 and 4. And we've exhausted our list. We could continue to 5, but 5 doesn't go into 12, and we can also see here that because we've got the numbers 1, 2, 3 and 4, and then we've actually got 6, 5 is excluded anyway, so there's no more factors of 12. Let's introduce now 6x, so we've got an algebraic term here and we're looking at factors of 6x, but we'll use the same logic as we did before, and we'll look for pairs of terms that multiply to 6x. So an obvious one is 1 and 6x, because 1 is a factor of all terms. Extending that, we can use 2 and 3x, and then likewise we can change the 3 and the 2 around to become 3 and 2x, and follow the same idea with the 1 and 6x and swap the 1 and 6 around to become 6 and x. So all of those pairs shown in the different colours, they're pairs that multiply to 6x, and we can list those as all the factors of 6x. Let's have a look now at the factors of 2k squared. So we've introduced a squared to the algebraic part of this expression. As before, we can start off with the number 1, and its partner, which multiplies to 2k squared, is 2k squared. We can then use 2, and 2 multiplied by k squared gives us 2k squared. Now we know that there are no other numbers apart from 1 and 2 which go into 2. So we can start switching around the k squared. Instead of being 1 and 2k squared, now we'll make it 1k and 2k. So that exhausts our list of factors of 2k squared. In this case, because we've got the k squared, we can start using a bit of mixing and matching with the 1 and the 2, but making sure at all times that we can get pairs of terms that can multiply towards 2k squared.